Good morning. So today we are going to see about first unit, that is algorithmic problem solving. So today we are going to see the first topic, algorithm. So what is meant by an algorithm? So algorithm is defined as a well collection of unambiguous and effective computable operation that are executed and produce a result and halts in a finite amount of time. That is, if we want to give a solution for a problem, first of all, we need to do some analysis, and based on that analysis, we need to give a description or a step-by-step procedure how to solve a problem. Okay, that step-by-step procedure have to be defined in well-ordered collection of unambiguous. Unambiguous in the sense it should be not in a repeated mode or not in a double meaning mode. Okay, it should be a single meaning and is precise and clear steps to be followed. For what it to be followed means to get effective computable operation and for execution. Okay, that too, it should be give a clear and effective outcome, and it should be halt in a finite amount of time. Okay, that is meant by an algorithm, or in simple words we can say it as a step-by-step procedure for solving a problem. So next, what is the properties of an algorithm? So these are some of the properties we need to discuss. So first thing, it should be written in a simple English language or normal English language, because a programmer may have a different linguistic in nature. A programmer may be an Indian, or it may be an American, or it may be a Chinese, or it may be a Japanese. So everybody should know a common language. So worldwide accepted language is English. So it should be written in the simple English and a normal frames. And second one, each and every instruction should be precise and unambiguous. So it should be clear. Okay, what is the input? How many input we are going to use? What are the variable we are going to assign it for that memory? So exactly the same we need to use in an algorithm. Okay, so next one is instruction. Is an algorithm should be repeated infinitely. Okay, it should not be repeated infinitely. Okay, if we are declaring a variable once, that's all. Only once we need to declare a variable. We should not declare many variables, and it will give a false result. Okay, so like that the algorithm should be. Then algorithm should conclude after a finite number of time. Okay, if we start the algorithm, there should be a terminator or ending. Okay, then only a programmer can easily develop a program and to create a output. Okay, next one is it should be an endpoint. It should have an endpoint. Okay, the next one is derived result should be obtained only after algorithm terminates. Once an algorithm gets terminated, then only the output should be shown. Okay, then only we can usually analyze those output in a proper manner. So next one is, which one says a good algorithm? Which quality factors says a good algorithm? So these are some of the common factors, primary factors that are often used to judge a quality of an algorithm. First one is time, next one is memory, and last one is accuracy. So time in concern, an algorithm which accumulate lesser amount of time for execution is said to be a good algorithm. Okay, that is the thing we have resembled there. The lesser is the time required, is better is the algorithm. And memory. So which algorithm accumulate less memory is said to be a good algorithm. The lesser is a memory required, the better is an algorithm. And last one is accuracy. So multiple algorithms having multiple options, multiple programs and multiple solutions, but which solution is accurately match the problem is a good algorithm. So these are the three factors which says the algorithm is a good algorithm. So next important thing is building blocks of an algorithm. To develop an algorithm, we can construct a basic building blocks, namely sequence, selection, and iteration. We will see one by one what it is. Okay. So first one is statement. So by this three things we are going to discuss in a many factors. In that first factor is statement. Statement is a single action in a computer. Statements are the single action in a computer. Why we are saying it is an action? whatever we are typing as a statement in a program, it will execute the output. In some other words, we can say those action in input data, process data, and output data. So input data is all about the informations giving to the program. Process data, the information which is given is get operated, and the input gets operated, and the output data, after the operation performed, it leads to a output, that is processed output. So these three are said to be a statement, single actions. Okay. So next one is state. So state is nothing but once the input data is completed, and it will leads to a second state called execution, that is process state. Okay, then it is leads to a output state. Okay, that's here it is noted. Transition from one process to another process under specified condition within a time is called state. Okay, so once the declaration for input is over, then based on the declaration, the process will be done, and based on the process, the output will be done, and with the output, it will display to the end user. Okay, so this is the process. Okay, this is about state. Next one is control flow. In the control flow, we'll decide an individual statement, executing the individual statement in a given order is called as a control flow. So these are the three orders, three ways of control flows: sequence, selection, and iteration. We will see one by one. First one is sequence. All the instructions are executed one after another is called sequence. Okay, for example, we will take it as adding two numbers. Okay, in adding two number program, there will be two inputs. That means two variables we need to assign, and that variable is get added, and the output will be displayed. So in an example, clearly they have given. So this is the example for an algorithm of sequence, adding of two number. We are starting the program. We will get the A and B. A and B is nothing but a variable of two numbers, and calculate the resultant is C. C is equal to A plus B. By adding those two variable, the output will be displayed, and the program is get stopped. So this is a perfect algorithm for a sequential type of control flow. So next one is selection type of control flow. So a selection statement causes the program to control to transfer to a specific part of program based upon the condition. If the condition is true, the part of program will be executed. Otherwise, they executed the other part of the program. Okay, so first it will decide by means of a condition. If the condition is get met, a process will be done. A condition is going to be not met, then that process will be going to be done. Okay, we will see an example so that we can clearly understand. When you see this example diagram, an input is given to a condition. The condition is going to be take a decision. If it is true, the action 2 is going to be performed. If it is false, the action 1 is going to be performed. Okay, so this is the better example for selection side. Okay, here I have given a real-time example. Write an algorithm to check whether he is eligible to vote. Okay, we are getting an age for that as an input, and we are checking an age with the criteria which is there now, that is 18 years old. So we are going to check with that age, with that 18. If it is eligible, then it will display eligible to vote. If it is not eligible, then it will go to the else part and it will display not eligible to vote. So this is the perfect example for selection process. Okay. So next one is building blocks of algorithm control flow iteration. Okay, iteration is nothing but it is also similarly like selection, but here we are going to test the condition. Based on the condition, if until the condition is met, the process is repeatedly doing. Okay, that is called iteration. So here a perfect execution type is looping. Okay, looping is the best example. So here in some programs, certain set of statements are executed again and again based on the condition test. Okay, once the condition is tested, it is met, the condition is met, the loop will be cancelled and it will show the output. Okay. For this, a better example is write an algorithm to print all the natural numbers up to n. So we are going to get a value n. So that value, till that value, what are all the natural numbers are available, we are going to display it. So when we met that n, the condition is n, when we met it, automatically the loop will be stopped and the output will be displayed. So this is the algorithm example. First the program is getting started. Next we are going to get an n value from as an input, and we are going to initialize it by means of 1, because natural number starts with 1. So our basic condition is I equal to 1. So if the I is less than less than or equal to n, we go to the step 5 and we are going to print the increment value. So the increment I is get incremented. So once it is get incremented, the one position is incremented as 2 and 3 and follow on. So until the n is met, the process will be repeatedly doing. Once it is met, again we are stop the program, stop the loop, and we are going to display the output. After displaying the output, we are going to stop the algorithm. So this is the very perfect example for iteration. I hope you are all understood this. Next we will see functions. Okay, functions plays a major role in developing a program. So function is a subprogram which consists of blocks of code or set of instruction that performs a particular task. So whatever specific task we are going to give an input or instruction, that instruction will be executed properly, and we are going to save it in a folder that called function. So whenever we require, we are not going to type those instructions again and again. We are just going to call the function alone. Okay, so that is about function. For complex program, the problem is being divided into smaller and simpler tasks during algorithm design. Okay, so this is the best example for, this is about functions. So next one is write an algorithm to find a rectangle. Okay, so at last we are going to see an example for an algorithm. So step by step example, we are going to find an area of a triangle. For a triangle, we require 2 input. So one is a length, another is a breadth, and for area of a triangle is a resultant. We are going to choose it as a. So first we are going to start a program, and we are going to get an input value, 2 input values, length and breadth, and it is saved in the memory called variable called L and B. And once they get the value, then it will be processed and it is calculated by means of A. So A is equal to L into B, that is length into breadth. So after getting the result, we are going to display the A and we are going to stop the program. So in this, all what we have discussed, the properties will be solved. See, first one is a well-ordered collection. So here finding the area of a triangle, here the well-ordered collection is there, and it unambiguous, perfect, not repeatable, non-duplicated steps will be shown here, and effective computable. So A is equal to L into B. So L into B is nothing but length into breadth. So once we are going to multiply the product, we are going to take the product of both value, you will get the exact area of triangle and then output, and we are going to show it as an output in a halt amount of time. After getting an output, we are going to stop the program. So this is about the algorithm. So thank you.